In today's business environment, effective supply chain management would simply not be possible without the use of information technology. And so it is very difficult to achieve the kind of levels of efficiencies that we're looking for in the supply chain, the level of responsiveness, or the ability to drive costs if information technology did not play a major role, if information technology was not a major enabler in helping to make supply chains very effective. Information technology, if we think of all, first of all the flows that go through a supply chain, we think of material flow, financial flows, and of course information flows. And those three flows are very important and need to be integrated. So information technology has to play a role that goes from one end of the supply chain, that is way back to the suppliers, through the organization right out to the customers. And so parts of the information system that is in place must be able to allow for internal integration, but also external integration. That is, integrating the company with its suppliers and its customers as well. So it makes the whole area of information technology and supply chain management quite interesting and quite fascinating. So there's been a lot of development over the years in the progress and the use of information technology in supply chains. So here's some questions that one would consider in ensuring that information technology is aptly used in the management of supply chains. One is, what is the impact of the business process change on IT implementation? So as companies search for efficiencies and greater profitability, often they will change some of their core business processes, and those core business processes can be in the supply chain, or it could actually be in other parts of the organization. But typically, IT has a role to play in enabling these process changes. What are the goals of IT from the perspective of supply chain management? What IT components are needed to achieve the goals? What are the supply component systems, and how should they be approached in the context of information technology? What are decision support systems and how they should support supply chain management? What criteria should be used in selecting decision support systems? And what drives the selection of what we call best of breed types of IT solutions? So these are some questions that one may want to answer um, in the context of matching the supply chain with the information technology. Now, a study by MIT, PRTM, and SAP showed that companies that only invest in IT without actually looking at their business processes, they do not necessarily achieve benefits. You have to actually invest in your business processes and your IT systems to get synergies. However, if there's going to be investment in just one area, at the very least, it must be predominantly in your business processes. So they found out that companies that invest mostly in business processes do better than those that invest only in IT. Because if you invest in IT systems that represents essentially just an automation of very inefficient processes, you're going to spend a lot of money just making inefficiency better. And you therefore do not reap any benefits from IT implementations or IT solutions that are not enabling better business processes. So investments only in technology without the appropriate business processes leads to negative returns. So some of the challenges then for supply chain managers is to identify measures that characterize supply chain effectiveness. And the idea is for you to know exactly how well your supply chain is performing. If you understand that, then of course you know that as you implement IT systems, what sort of benefits are being accrued from the respective implementations or respective strategies. And then develop measures to characterize the level of maturity of the business process and information technology employed by the company. And the reason for that is because by understanding the maturity level, you know what kind of investments are necessary. So is the IT systems system mature, or is it in its infancy? Are your business processes mature, or are they in their infancy? And depending on where the organization is, if you have immature business processes, you do not attempt to have mature IT systems in an environment like that. It just doesn't make sense. So let us try to understand a little bit about the maturity level of business processes. So level one is where your processes are totally disconnected. They are independent processes, organized functionally, and you have kind of silo strategies where each area is actually functioning without a certain level of integration. There's a lack of clear consistency in terms of how the supply chain is managed, and then typically there are no measurements, or the measurements, if there are any, are not necessarily aligned to the objectives of the company. So there's, more or less a chaotic environment is what we're talking about here. You have some level of internal integration at level two, where the organization is still organized functionally with a high degree of integration. Decisions are made through the integration of key functional areas. So key functional areas connect with each other. Some information is shared. They may have some common forecasts that is applied throughout the organization. So we have integration of some functional information. Documented processes follow across the entire organization, and there are some departmental measures, not necessarily company-wide measures, but departmental measures. So that's level two. Level three, there is some intra-company integration. That is, if a company has several different divisions or parts, then those divisions do some level of collaboration. So it's cross-functionally organized, involves key suppliers and customers in decision making. So even some of the customers and the suppliers are integrated into the decision making process of the company. So decisions are optimized across the internal supply chain, sophisticated processes that involve all the affected parties are sort of utilized, and some key customers and suppliers are often included in the decision-making processes. But level four now is where you get complete integration, not just internally but also externally as well. So it's a multi-enterprise processes. You look at the processes across the organization, but also outside to the customers and the suppliers as well. You typically try to do some alignment of your business objectives with that of your suppliers and your customers, so that brings a further level of integration. And then it is possible that in the collaborative process that some of the trading partners could actually operate with your organization as a virtual corporation. So by sharing information, by creating opportunities for the companies to link their systems, then you could function as a virtual corporation if you have that level of integration. So characteristics involve collaboration across the entire supply chain. You have internal and external collaborative supply chain management, and that focuses on common and service and financial goals. So those goals would have to be shared among all the partners, and measures directly link supply chain results to company goals. So in other words, the initiatives that are undertaken by these companies try to ensure that there's a link between the supply chain goals and the company's goals. All right. So if the company has goals around, say, expanding into new markets, then the supply chain objectives have to be able to enable capture of new market share and so forth. IT systems have their own categories. You have four categories of IT systems. And again, remember we talked about business processes need to be matched up with the IT systems. So level one, categories of IT systems. Level one is basically just batch processing. Things are done. You have independent information systems that are fairly disconnected, and each of them, they may share some information, but each of them are run independently. So focus on spreadsheet and manual manipulation of data for decision making. And then different departments would have their own spreadsheets and so on. So there's really no level of integration happening here. Level two, shared data across the supply chain. Decisions are made using planning tools. So you could actually plan across the supply chain, and but still the level of integration is reasonably low. Then level 3, complete visibility of the internal data. So key suppliers and customers have access to some of this information. So some of your suppliers may know what your inventory levels are. Some of your customers will know what do you have in stock in your warehouses, and so on. Processes are also shared across the supply chain. And level 4, data and processes are shared both internally and externally. So you have a fair amount of integration by the time you get to that level. All right. So here are some areas of data collection. When we think of managing the supply chain, one is for strategic planning purposes, where we need to think about decisions around the network design. Where do we position inventory? What is our manufacturing strategy? Make to stock or make to order. Demand planning, so that we could do some forecasting across a network and do some promotional planning. Supply planning, that is to coordinate manufacturing and distribution. The inventory levels, transportation, so all of those parts need to be coordinated as part of the supply planning. Supply demand balancing, the whole idea that supply and demand needs to be balanced, and this is where you get into some of your pricing strategies. So the trade-off between suppliers' capabilities and customer demand are considered. So pricing and promotional activities, one thing to influence the demand, but at the same time we have to make sure that that demand is such that it matches the available supply. And so there has to be this balance. Procurement planning, materials and commodities, sourcing strategy. So understanding who your suppliers are going to be and what they will supply you in what quantities and when. Manufacturing planning, single site versus enterprise-wide strategy. So how do we manufacture the products? Do we allocate production of particular products to single sites, or do we actually manufacture across a number of different sites and then ship or transship the manufactured goods to the demand points? Delivery planning, commitments to customers are based on forecasts, available capacity, real-time inventory, and so forth. So you could use information technology to assist in all of these aspects, okay, of supply chain management. There's some major benefits that are accrued from effective use of information technology. Of course, companies with mature business processes tend to have low inventory levels. Improvements in certain areas demand IT investments. So to enable process improvements, IT can usually enable that. BICS companies with mature processes achieve superior financial performance. So, excuse me, the ones that have good business processes, efficient and effective business processes, tend to make more money. And of course, we've already said that if you only invest in information technology, then that does not necessarily lead to good results. In fact, you get greater inefficiencies. And then the investments in information technology ought to depend on the objectives or the business objectives of the company. So here's a bit of matching between our business processes, if they're mature versus immature, and IT systems, if they're immature versus mature. And we could see here the relationship between these two dimensions, the business processes and the IT systems. So in the case of A, where we have immature business processes and immature IT systems, you're going to get below average performance. So we clearly have a lot of work to do here, where we need to update the business processes and match the IT systems to go along with that. If we have mature IT systems and immature business processes, then you're not going to get efficiencies from that, because all you're doing is automating inefficient or immature business processes. So the systems are not complemented by the planning practices. If we now go to immature IT systems and mature business systems, then what happens is you're not supporting your businesses, your business processes well enough. There's an opportunity, for improved bottom line, and you could potentially improve it by up to about 27%, according to this research here. Last but not least, is that if your IT systems are mature and your business processes are mature, then there's alignment between your planning practices and your systems, and you have significant improvement on operational performance and you could actually do up to 75% higher on profitability for those companies that are well aligned. And so this slide essentially just reiterates what I just discussed in that last slide. So the goals of the supply chain, there are several goals for supply chain IT. Desired goals of IT as they relate to the supply chain management and its unique requirements. So we need to make sure that we understand what the goals are. Some companies and industries have a long way to go to actually achieve their IT and supply chain related goals, while some others are making progress. So let's see what are some of these goals. Typically, we look at the collection of information. So we want to know the information about the actual products themselves. What is happening to that product from the point of purchase to delivery. So we want to provide complete visibility to all parties. So for example, the supplier should know what's going on, the company should know what's going on, the customer should know what's going on. Access to data at any point in the system. So some kind of what we call a single point of contact. Anywhere you should be able to, in other words, if you need information, you don't need to actually go to a different computer system or a different interface. You ought to be able to use single staging, where at one point you could access information about any part of the system if you have your IT infrastructure properly designed. You got to be able to do some analysis, so analyze, plan activities, and make trade-offs based on information from the entire chain. So the ability to analyze, the ability to access, the ability to collect information, and the ability to collaborate. So these are 4 core system goals that we're talking about: collection, and access, analysis, and collaboration at that point. So the goal is, primary overall objective is to link the point of production seamlessly with the point of delivery or purchase. So we want some seamless integration here. Have information trail that follows the product's physical trail, allows for planning, tracking, estimating lead times based on real data, and any party has an interest in the whereabouts are able to find out or have access to information. So we see here collecting information, accessing the information, analyzing the information, using the information to collaborate. Yeah. When we think about information flows in the supply chain, we can see here that in terms of information, we have intra-firm suppliers and the manufacturers. We have intra-firm between retailers and warehouses and so on. And then you have these are inter-firm. And then intra-firm is between the parts of the company that are owned, these warehouses and manufacturers. All right? And so we have to manage all of this. So let's look at the collection of information. We're looking at the sort of 4 parts of the IT system. So we have to know something about information requirements. We have to, so in other words, the status of retailers' orders. Suppliers need to be able to anticipate an incoming order from the manufacturer. So that's kind of the kind of data that we need, some of the kind of data that we need to have as part of that IT system. Data access requirements, so from other companies, some companies have special requirements in terms of accessing data. And from one function to the next internally, or even geographically, inside of the company. This is a sort of intra-firm kind of data requirements. The company to be able to provide data access as well. Often, to be able to share information, it requires some level of standardization. So barcoding can certainly help. And then, of course, being able to track in the products and locate them, RFID technology can certainly help as well. In terms of accessing the data, a single point of contact. So all of the data should be able to be accessed in a sort of a one-stop one-stop shopping kind of approach. All right, so you should be able to access a database and then perform what kinds of inquiries that you want to. Essentially, if you want to use phone, fax, internet, or whatever, somehow you should still be able to access that information. That information should be centrally located or centrally available, so it makes access relatively easy. The information may reside in various locations within the company, However, access to that information, all that information should be possible from a single location. All right. Current information systems, as you can see here, when we think about current practices, there's a lack of integration. All of these things happen almost separately, but the new generation of information systems look at a single point of contact, and the accountant could access it, the sales representative could access that, the demand planner, operations, and so on. Everybody have access to the same information. That allows for consistency across the entire organization. On the analysis side, so based on the supply chain data, so we are able to conduct a fair amount of analysis, statistical analysis, and so on, if we're able to capture data, have it in an appropriate form. So data analysis should take into consideration the global supply chain picture. In other words, not just parts of the supply chain, but the entire supply chain. And the information system ought to provide the opportunity to find the best ways to kind of produce, assemble, warehouse, and distribute products. All right, it's supposed to be able to assist in that. Sometimes we require different levels of analysis. The analysis ought to be, some cases need to be strategic, it needs to be tactical, it needs to be operational. And these are three different levels of planning: strategic being the long term, tactical being medium term, and operational being short term. So these kinds of analysis are often necessary in the supply chain, and information must be able to support it. Systems need to be flexible enough to accommodate changes in the supply chain. So as you make changes in your supply chain, you do not want to be in a situation where your information system becomes your Achilles heel. It has to be flexible enough to be able to change along with that system. And systems need to be highly configurable, and new standards need to be developed. So as standards change over time, the IT system need to be able to change along with that. And of course, collaboration with supply chain partners, we've already mentioned, the ability to share information, to engage in in decision making is extremely important in managing the supply chain effectively. So collaboration among the partners often requires the ability to link and work effectively with the suppliers, to be able to share information that each person could access and interpret in pretty much the same way. And then, of course, in terms of helping to manage supplier relationships as well as customer relationships, the information ought to be able to enable that as well. All right. Here's an example of how 7-Eleven was able to demonstrate these 4 supply chain goals, and we said do data collection, data access, data analysis, and collaboration. So it collected data item by item, store by store, day by day for the last decade, while other retailers only collected point of sales data at best. All right. So mobile operations terminal, so that is a single point access. A lightweight wireless tablet with a colorful screen that allows access to information in the store and allows recording of inventory changes. So that's your access aspect of it. Analysis, retail information system, install and store support, provide timely sales data that enables each store to tailor its product assortment according to its customers. And that is where you do analysis with that data. And then supplier collaboration enable the sharing of 7-Eleven's data analysis for a program called 7 Exchange. And that information allow better collaboration between its suppliers and the company. Some key supply chain management system components involve, we'll talk about 2 key elements, ERP systems and decision support systems. ERP systems, as you know, stands for Enterprise Resource Planning. And Enterprise Resource Planning, if you want to do planning at an enterprise level, it means that you have to be able to collect information, collect data at the level of the enterprise. And so we know about SAP, PeopleSoft, and so on, Oracle, I believe it is called. So all of these systems allow us to integrate the business functions throughout an entire organization. So the attempt to resolve, bring all business functions together to make an enterprise more efficient. They do not help answer the fundamental questions of what should be made, where, when, and from whom, because they're not typically are not decision-making tools. They're basically tools that collect information and gives you sort of an enterprise view of all the major data that is necessary for making decisions. Such decisions are made by human planners using various analytical tools referred to as decision support systems. All right. And now decision support systems range from spreadsheets to expert systems, and the kind of decision support system that you need depends on the complexity of the organization, the kinds of problems that you often want to solve. And DSS helps in analysis at various planning levels, for one, and the exact nature of the decision support system will depend on your manufacturing characteristics, your demand, fluctuation, transportation costs, your inventory costs. So there are a lot of drivers that actually will shape your decision support system. You can do queries, statistical analysis with decision support systems, because if you collect vast amounts of data for your ERP system, then you can actually access that data and perform a number of queries. This is where you get into the analysis using that data that has been collected or mined, and you could actually generate information from that. So data mining, as you can see here, and the use of online analytical processing tools, all of these are used in decision support systems. Right? Of course, it's important that for decision support systems to be effectively used, that you have good interfaces that allow the decision makers to access the information, run the analytical tools, and then get results from it as efficiently as possible. So display and report it based on the specific problem being solved, and uses analytical tools that have some specific embedded knowledge of the problem being solved in itself. So these things are internal to decision support systems. You could have calculators. You could do simulations in decision support systems. Some decision support systems have artificial intelligence built into them, where the systems actually collect data and they inhibit learning patterns and so on. So the software actually collect information, could do some communication, interact with other agents and so forth. Expert systems essentially the software that could be taught how to make decisions, and as a decision maker makes those decisions, the expert system learns the rules that were applied by the decision maker and could then automatically make some of those decisions in the future. So you have to have a fairly extensive database with a lot of experience that is then used by the software for learning purposes, and eventually be able to make some of those decisions in the future. All right. There are some other analytical tools. You can use mathematical algorithms, some exact algorithms that will try to solve the problem optimally for you, or heuristics that are a set of rules that give you as good a solution, hopefully, but not necessarily the optimal solution. And in a lot of cases, the optimal solutions are not practical because they may require some extreme decisions. And so we often need a compromise solution, and heuristics tend to be better at producing some of these compromise solutions. All right. The appropriateness of different tools. So the tool that you would use within a decision support system will depend on the problem context. So the type of problem being solved, the accuracy of the solution that is required, the complexity, number, and type of quantifiable output measures, the speed, because to get the best solution sometimes could take a very long time. If you need a solution very quickly, you may have to settle for heuristic, and the number of objectives or goals that the decision maker has to consider. So application of these tools, analytical tools, you can see that they can be applied in marketing, routing, production scheduling, network configuration, mode selection, and so forth. And the different types of tools that are used, we use queries, statistics, data mining in marketing, heuristics and exact algorithms in routing, simulation heuristics, and exact algorithms as well too, or dispatch rules in scheduling, exact algorithms, heuristics in simulation, heuristics, exact algorithms in mode selection. So all of those are considered. In terms of capabilities, you must have some capabilities for supply chain excellence. So your IT capabilities involve several possibilities. One is to be able to pick the optimal number, location, and size of warehouses. So helping to build your network, your supply network structure. Determine the optimum sourcing strategy, so which supplier should you use. Determine the best distribution channels, for which channels should your products be sold. Minimizing costs, maximizing profit. A number of objectives that include optimizing transportation, the warehousing, keeping inventories as low as possible, looking at the trade-offs between number of facilities and service levels. So in other words, planning the infrastructure. If you have more distribution centers, you could actually shorten delivery lead times, but then it costs you more money. So you have to balance between the cost of that and the service levels that you're trying to provide. And planning horizons can vary from many years, that's strategic, to months, which is operational, and uses both aggregated and disaggregated data. So IT capabilities support tactical planning. Tactical planning has to do with sort of more medium-term planning, where we get into what we call supply chain master planning. Coordinates production, distribution strategies, and storage requirements. So that's typically done over a period of about 6 months to 18 months. So that's intermediate planning. Inventory planning determines the optimum amount of safety stock and how best to position inventory in the supply chain. So which distribution centers, whether or not you position inventory in a central distribution center versus distribution centers that are decentralized. So those kinds of decisions tend to be tactical in nature, because the planning horizon would typically be sort of medium term. Now, the decision to determine whether or not to have a central distribution center and a number of decentralized or local distribution centers, that's more of a strategic decision. But once you have that infrastructure, how do you position inventory within that? That is actually much more tactical planning. All right, and operational planning have to do with sort of more day-to-day, week-to-week types of activities or decisions. It enables efficiencies in procurement, production, distribution, inventory, transportation, pretty much short-term planning. So if we have to distribute products this week, then do we use third-party logistics? What is the distribution schedule? On what day do certain products go out? That level of detail is actually part of operations planning, and IT can enable all of those things. So 4 components of operational planning, since that is where we do a fair amount of activity with IT support as well, is to do some demand planning. So we are able to generate forecasts based on historical information, do some statistical analysis. Production planning, so we could actually schedule the production of individual products, develop a master plan, and then looking at our capacity limitations and determining how best to satisfy demand with our current capacity constraints. Inventory management, generate inventory plans for various facilities in the supply chain. Statistical and computational methods are typically used. And we already mentioned transportation planning to determine what's the best routes, the fleet optimization, best transportation mode to use, and so forth. So all of these elements of operational planning can be enabled through IT. In terms of operational execution, the execution of the operational decisions, IT clearly plays a major role in that as well. And there are several components of operational execution. We often think of enterprise resource planning, ERP systems that do a lot of data collection for us. But we must also now use that information to manage the relationship with your suppliers and your customers, and then to look at the supply chain management systems that we have in place, as well as transportation systems, and support all of those with that information that we obtain from the ERP system. There's some other factors to consider. Planning horizons are different for different capabilities. So if you want to have strategic capabilities, planning horizon is different. Tactical capabilities, operational capabilities. The return on investment tends to be different for the different systems. So it tends to be high for strategic systems. Why? Because the investment in strategic systems is very expensive. And so if you are able to optimize and utilize IT capabilities very well, you could achieve significant savings. There's a lot of complexity, and the complexity sort of differs as well depending on the application. In a strategic network, the complexity can be a bit less, but on a day-to-day basis, when we're doing operational planning, where there's so many elements that have to be coordinated, the complexity can be a lot higher. And so, in terms of having certain capabilities at the operational level, there's a fair amount of complexity that requires significant IT capabilities as well. Integrating supply chain IT, we need to keep in mind that systems can be complex, that there are costs associated with implementing these IT systems, that while we consider the implementation of ERP systems, they often require major cultural shifts in an organization. They require a lot of time, a lot of effort and energy, and internal processes, a lot of cases have to be converted to suit the ERP system, as opposed to the ERP system being converted to suit the company's environment. So there's usually some industry conventions, but not necessarily standard across all industries. And that shift from converting the current business processes to suit an ERP system is one of the factors that have led to failed implementations of a lot of ERP systems, because companies weren't fully ready for the dramatic shift or dramatic changes in its processes to match the ERP system. And so when companies are doing this implementation, they have to decide what their priorities are, whether they should invest in the decision support systems or ERP systems first. So here's just some implementation of ERP and DSS. The length's a lot longer for ERP systems compared to DSS, decision support systems. The value is in terms of operational planning here, because it collects a fair amount of data. And usually the infrastructure is already in place and the ERP system matches that infrastructure. Decision support systems can provide support for tactical, operational, and strategic planning. Return on investment happens in 2 to 5 years. 1 year payback, you could actually see benefits. Users, all end users, and usually a small group within the organization. Training can be simple here, it can be very complex in this case right here. Implementation issues. In terms of decision support systems and ERP systems, decision support systems should use the data that comes out of an ERP system. So companies must first install the ERP so that the data is available. But you can actually do some implementations in parallel, because there's often some data that is already available through your legacy systems that can be used by the decision support system. But then, as the ERP system is being designed, we must ensure that the decision support system could actually take advantage of the data created by the ERP system. All right? And depending on your kind of organization, we could see where the emphasis ought to be. So in terms of industries, if you're a soft drink distributor, your decision support systems can support network and transportation, computer manufacturer demand and manufacturing, consumer products demand and distribution, and so forth. So we begin to see the benefits, or certainly the applications of the decision support system. Finally, when you want to select the kind of system, what do? Do you just get a single vendor who will provide both your ERP and DSS? So for example, hire IBM to give you your ERP system and your DSS? Or do you go after best of breed approach, which is where you get the best in each category, in each industry? So get the best ERP system for ERP systems, then look for the best decision support systems from the decision support industries and so on, and then you sort of put them together. So you purchase the best fit solution in each category, and then you do some integration right here. Typically it's more complex, takes longer to implement, but it does provide greater long-term flexibility and it provides better solutions overall to the company. You could also do proprietary systems where you design a system from within if you have a large IT department, and that system, however, is really tailored to your company's needs, but changes to it can become quite cumbersome because of the fact that the system was designed so specifically for a situation, and any changes in the company's structure might make it very difficult to implement new designs and so on later on, particularly if some of the people who design that initial system, that proprietary system, are no longer with the company. So we see here the lengths, 2 to 4 years for best of breed, 12 to 24 months for single vendor, and it's not quite known how long the company would actually take to design its own. The cost depends on the expertise, higher for best of breed, lower for single vendor. Flexibility is higher for best of breed, but lower for single vendor. Highest for proprietary systems because you design it to match your own company. And we see the complexities, quality of solution fit to the enterprise, and so forth. So these are some attributes of the implementation and how these actually perform on these various attributes. So just to summarize, that we remember that there are four major IT goals. We talked about collection, access, analysis, and collaboration, and information availability on each product from production to delivery point. So we have to collect that. Single point of contact, which deals with our access, using that information to make decisions based on the total supply chain information, and of course using that information to be able to do collaboration, effective collaboration with all of these supply chain partners. So information technology plays a crucial role in enabling efficiencies and effectiveness of any supply chain.